Hello, welcome back to the Geography 300 video series for Geographical Data Analysis at WVU. This video, as you can see since I left the scatter plot here, builds upon the previous video and puts the ideas we've seen before of the intercept, the coefficient, and the overall relationship, beta 0, beta, and r squared, into our inferential hypothesis framework. And what ends up happening, each of these three has basically its own separate hypothesis test, at least as we interpret it. They all happen at the same time. It's not running three separate things within ARC or within Geoda, but basically three separate null hypotheses, three separate alternative hypotheses, three separate p-values to interpret. So, now we start here with the interceptor, beta 0. And it's saying, is the null hypothesis is that the intercept is 0. So that this red line could hit here at the origin, basically at 0, 0. The alternative hypothesis, that it's not 0. Can be greater, can be lesser, positive or negative. It's just not 0 as the alternative hypothesis. So we get our p-value for this, and it tells us, is my intercept equal to 0 or not? Now this might be something that is of interest. It might not be anything of interest. So an example where it may be of interest would be say in a political context, to say, okay, I might be interested in, at the county scale, the percent supporting, I'll just pick with the current presidents, the percent supporting President Biden in the 2020 election as my dependent variable, and the median income of the county as the independent variable. So this could mean, as a county gets richer, support for Biden increases. It could actually mean support for Biden decreases. What we would be saying here is, for the intercept, basically, is there a baseline of support where the income equals 0? Okay, I had said for an example where it would make sense. This actually is one where it doesn't. I'm sorry. Because we'll never come across a county with an income of 0. I don't care what this theoretical value would be, whether it's equal to 0 or whether it's not, because I'm never going to encounter that county anyway. But if I change this independent variable from say, income to college education rate, this is by no means not guaranteed. It is not guaranteed at all especially at the individual scale, so we're staying away from the ecological fallacy here. But by and large, as within a community, as more people have college degrees, they tend, right now at least, to have stronger community support for the Democrats. So okay, I might have that as my regression equation, my regression relationship. This time I can picture a county where nobody has a college degree. Is there some baseline level of support for the Democrats that would happen regardless? Some baseline support for President Biden, even if nobody had a college degree. If I go with the null hypothesis here, that would say, yeah, there's no baseline support. And where there's no college education, there's no support for President Biden. And it just goes up from there. Or, for this intercept, is there, for the alternate hypothesis, then it would say, yeah, I go up. There is some baseline level of support, even if there's no college education in a community. That is an example where I might be interested in that intercept. So that's the intercept, and I get my p-value. As always, the p-value is the probability that the data supports the null hypothesis. And as always, recognize that basically there's a confidence interval in this intercept, because the data could have sampling error, there could be other problems with it. So it could go up or down, and does that confidence interval include 0, 0? And if it does, I go with the null hypothesis. If it does not, then I go with the alternative hypothesis. That's the probability the data supports, for the null hypothesis, that the data supports that the intercept is or could be equal to 0. That's the inference as applied to the intercept. Now inference applied to the coefficient. It's actually quite similar. Geometrically, as I said, that's where the line intercepts the origin. The coefficient, it's again the null hypothesis being that the coefficient is 0. Alternative hypothesis that it is not. Okay, remembering this is the slope of the regression line here. If the coefficient is 0, then it's flat. If the coefficient isn't 0, it is angled up for a positive slope or positive coefficient, and angled down if it is a negative slope or negative coefficient. This is something where basically we're pretty much always interested in this particular value and its associated p-value. Okay, so what would that associated p-value be? Well, the probability that there's a relationship, the probability that this slope is flat or not flat. If that probability is low, 0.05, 0.1, 0.01, whatever we set for our threshold, if that's low enough, then I say, okay, my slope is not 0. That particular independent variable does have a relationship with the dependent variable. So, does income have an effect on the county level support for President Biden? Does college education rate have an impact on county level support for President Biden? Instead of the baseline, that is the intercept, this time we are really looking at that relationship between the two variables. And as I said, we're pretty much always interested in that. And really we're kind of expecting there to be some kind of low p-value to tell us there's a relationship. Much of the time. Not always, but much of the time, because I would not have hypothesized a relationship here. I would not have developed that null hypothesis in the first place, or alternative hypothesis, if I didn't suspect this was something worth studying and that there is actually a relationship there. That p-value is telling me how likely is it that the data says there's no relationship. I want this to be low, the p-value to be low, to tell me there is a relationship. Now let's move on to r squared. In this context, r squared is going to be really, really similar in a way to the coefficient, except the r squared, the null hypothesis again that it's zero, that there's no relationship. Alternative, it's greater than zero. Remember, it can only go from 0 to 1, so I can put greater than here. And there is an overall relationship within my data. Where these two become distinct from each other is in next week's, the next set of videos, building on this idea of bivariate regression. Right now, if this coefficient is significant, this overall relationship will also pretty much always be significant. So, and the p-value is interpreted the same way. The probability, the data supports this idea that there's no relationship, which is the null hypothesis. So, we've now covered inference on the intercept, inference on the coefficient, inference on r squared. So, as always, if you have any questions, please feel free to email or speak up in our Zoom class sessions, and I will see you at the next video. Have a good one.